Wind is caused by the pressure gradient force. Air seeks to equalize pressure differences and therefore flows out of high-pressure areas into low-pressure areas. Imagining highs as hills and lows as valleys, like in this drawing by Eric Sloan, illustrates why air flows in this direction. The steeper the hill, represented by closer together isobars on a weather map, the stronger the airflow. If this were the whole story, wind would flow straight out of high-pressure areas and straight into low-pressure areas. But there is also the Coriolis force. This is an apparent force caused by our rotating globe, which, in the northern hemisphere, causes all air movement to deflect to the right. This hill illustration, again by Eric Sloan, shows which direction this rightward deflection goes. In the air flowing out of the high, the right turn is clockwise around the hill, and in the valley, the right turn is counterclockwise down to the bottom. Pressure gradient force is basically just dependent on pressure difference, but Coriolis force is highly dependent on wind speed. The higher the airspeed, the greater the deflection. At high airspeeds, like those often found at higher altitudes, the Coriolis force dominates, causing the winds to flow nearly parallel to the isobars, making circles around stronger highs and lows. However, if something causes the air to slow down, the Coriolis effect diminishes and the airflow angles out of highs and into lows. That something is surface friction. It is caused both by large topography like mountains and hills, and smaller features like forests and cities. Any slowdown in the airspeed will cause the wind to angle back to its left, as the Coriolis effect diminishes, but the pressure gradient force stays the same. In this question, B is wrong because Coriolis force is in fact reduced at the surface, and C is wrong because pressure gradient does not depend on altitude. The difference in wind direction is caused by answer A, surface friction.